Hey everybody, thank you for joining us for our session on Azure Databricks. We are going to begin here in just a second with Max Mogenis and John Bloom. They are doing a co-presentation. So Max, I know you're up first, so whenever you're ready, feel free to go. And if I see someone has an echo. If you have an echo, that probably means you have multiple Crowdcast tabs open, so just one Crowdcast tab.
All right, well, thank you very much, Liz. Welcome everyone, thank you for attending. So here's our agenda. I'll start off with who I am, and then what are we going to focus on in this session? We're going to take a look at the Azure Databricks cluster and why is it important? It's a foundational building block. Next, we'll look at the ecosphere of Databricks as it relates to the cluster from both a functional and architectural perspective. From there, we will go into instance type selection. And we'll also look at some of the factors influencing clusters and considerations around the cluster. We'll take a look at the underlying Azure infrastructure. We'll look at some cluster sizing starting points, some best practices, briefly look at how to construct data sets for development, and then finish off with high availability and disaster recovery. Who am I? I'm Max Mogenis. I am a senior consultant at Pragmatic Works. I'm a data geek. I've been focused on data architecture, engineering, and solutions architecture in the BI space for too long, and I don't want to share that. But I will leave my email address up here for about 45 seconds to a minute, just so if you have any questions, feel free to email me after the session. And I will not be taking questions because I want to make sure that John has enough time. I think his topic's a little bit more in depth and will generate more questions than mine, but feel free, please, to email me at mmogenis@pragmaticworks.com, and I will follow up with you as soon as I can. So 15 seconds and we'll move on here, just in case anyone wants to write down my email address and send me notes, comments, questions, what have you. Okay, let's move on. So just one caveat before we get going. What are we not going to cover in this session? We're not going to be covering performance tuning. That's an in-depth topic that should have multiple sessions dedicated to it in order to give it a proper treatment. Okay, so why is the cluster important? Underlying everything, it's the basic unit of foundation for Databricks. And it's the base functionality that sets the stage for performance and scaling for workload type. Next, we'll take a look at the ecosphere from both a functional and a architectural perspective. So this slide, and if you read it from left to right, you'll notice on your left-hand side that you have the multiple sources of data. So one of the key things about Databricks and the clusters is that it allows you to integrate multiple sources of data into the Azure ecosphere. So you can harden them into blob storage, data lake, so on and so forth for storage, and then you're able to take traditional structured data such as SQL data or data from data warehouse, non-structured data such as Cosmos database providing a source. You can also have streaming data being provided by an event hub, IoT data, so the Internet of Things data can be provided via an Azure hub as well. And you can use Azure Data Factory to source the data, to pull it in, to stage the data, transform the data, and reload it so that you can then integrate the data. And this is the magic of Databricks here in the center. And if you notice, in the top part of the column, you have the collaborative workspace. So this is really where data engineering and data scientists meet. So you have the collaborative workspace comprised of metadata in the form of notebooks, models, dashboards, and then also executing against it are jobs and the APIs. So, and this all sits on top of the Spark mechanism of Databricks, and it allows you to do a lot of high-powered analyses and transformations and so on and so forth of your data, and that sits on top of the Azure backbone. And so you really have infinite scale potential when you think about it, and it's incredibly mind-boggling how much power you can leverage. And so the end goal, of course, is to have visualizations in the forms of dashboards, reports, KPIs, and this is all integrated within the context of Azure Active Directory security. So let's move on now to the Azure Databricks infrastructure. And so would like to call out that this is a more detailed view. And so the main thing to really recognize here is that legacy systems and more current technologies are integrated securely within the context of the Azure Ecosphere. And so if you notice on the top box to the center, you'll notice that you have the control plane. So that would be the collaborative workspace that we were talking about. And then notice that there's a TLS pipeline between the two boxes. That is your security and pipeline. So both data at risk and in flight is encrypted via the TLS platform and mechanism for security. So that allows you to connect your metadata, your notebooks, your logs, and other facts while they're sitting within the Databricks interface. And then underneath of it, that's where your infrastructure provides you the clusters. And then that's also integrated into all the other wonderful components and pieces of the Azure Ecosphere. So the way I like to think of this is it's kind of like Legos in the sense that all these pieces interconnect, they all play nicely together, and they're engineered so that they work together. So there's a lot there, and there's a lot of really amazing capacity and capabilities with the system. So let's move on now. If we're gonna choose an instance type, what are the factors involved? How do we lay the foundation by selecting the right tools for the task at hand? And what are the factors involved? So one of the main considerations that we want to take into account is that it's the workload. What type of workloads are we going to be? What type of work? How are we performing it? And then the underlying piece of this is that you have the Azure instance types to support both the cluster and the workload types. So it's kind of a chicken and egg question in that they one begs the other, and then the other reinforces the latter. So what are the cluster types for workloads, right? So one of the things to keep in mind is that clusters are transient and can be provisioned per workload type. So one of the things is for your lower environments, for your development, your testing, your systems integration and QA, you can spin them up. Whereas a more persistent environment, production, you would leave those running. And so you have different dynamics across those types of environments. But anyway, let's step back a little bit and look at the types of workloads. So you have machine learning, and usually that is contingent upon being memory optimized to fit the data in memory so your algorithms and libraries can run against it and learn against it, do the analysis, and then return the results. For a streaming scenario, you'd want a commute optimized versus a processing rate. ETL, you would be memory and CPU dependent, as well as disk I/O. Interactive development, you would want to use the default settings of auto scaling and auto termination out of the box, so that a developer doesn't leave the resources up and running for a long time and you're being charged for it. Production. So you want to increase the cluster size and resources to account for load variability. You also, it allow you to baseline and track and adjust over time to load data volumes, processing times, and so on and so forth. So underneath of this, these cluster types, we have the Azure instance types that support it. And a lot of times people just select out of the box and say, hey, build me a cluster, and off we go. And then they run into a scenario of like, hey, things aren't performing, right? So some of the things to bear in mind, and going back to our earlier scenario, whether we need a compute optimized for, say, machine learning, you have a couple different options. You have the FS, you have the H, and so some of it, the main differentiators here is that you have the core and RAM allocation, as well as the storage, the disk behind it. So how much is allocated per core? So for memory optimized, like for instance the DSV2 or the ESV3, here your core to memory ratios are higher. So and then also your core to SSD. So where you're having to, like for an ETL type of scenario where you're having to do a lot of reading and writing and then work in memory, these are your options to be considerate of. And I believe John's going to be talking to ETL in the next half of this presentation. And then also you have like a storage optimized, so you have high disk throughput and IO. So this would be really good for big data, SQL and NoSQL databases, and then a developer general purpose type of box might be a balanced CPU memory ratio. So this would be ideal for testing and development in small to medium databases and low to medium traffic web servers. So now I'd like to move on and talk about some of the rules of thumb for cluster sizing, right? And one of the things to really take into account is that you want to break your bigger instances down into smaller instances. So you don't have these ginormous instances per cluster. You want to tackle the problem by throwing smaller instances within the cluster. So one of the advantages of this is it reduces the network shuffle. So Databricks has one executor per cluster machine, and so within the nodes, the work is being performed. So, and need to talk a little bit at a higher level as well as the Azure or the Databricks infrastructure is that you have a compute node and a data node. So within these computing nodes, you overlaying it, you have one executor that really serves as the coordinator, making sure that the data, the jobs, all of it gets distributed across the cores, and then the parallel processing occurs. So this applies to batch ETL processing mainly. For streaming, you could start with smaller instances depending on your complexity of transformation. And also, this is not set in stone, right? And sometimes you may want to start with smaller instances and then work to bigger instances. So it's kind of, if you've got experience in database tuning, you're really working towards probabilities, right? And sometimes things become counterintuitive, and that's really what I'm trying to call out in that. Also size based on the number of tasks initially and then tweak later. So starting the job running with a small cluster gives you the number of idea per tasks per core. And so you're trying to drive to 2 to 3 tasks per core for base sizing. Once you have that dialed in, then you can start tuning accordingly. Choosing based on the workload, right? So you probably want to start with an F series or DSV2 that we showed in the previous slide. So again, going back to those types, the ETL with full file scans and no data reuse, an F or a DSV2. Machine learning with data caching, you would want to start with a DSV2 and then go to an F. And again, data analysis, you would probably want to use an L, and streaming for an F. Okay, so carrying on, again, another area of where using fewer bigger instances and using smaller instances becomes significant is the garbage collection. So when you have a larger instance, you have a larger heap, and so when the garbage collector has to clean all this up, there's more overhead to do that. And when you break this down across more instances that are smaller, it actually becomes more efficient doing this. And one of the impacts out is that you're reducing network shuffle, so you're not sending redundant data sets across processors and then having to use a network resource to do that. And we'll talk a little bit more about networking and data relationships. So, and again, you want to size based on the number of tasks initially and then tweak them later. So start small and work bigger, so you can figure out what your distribution of workload across cores and tasks are, and then go from there. Also choose, you want to choose based on the workload, right? Start with a C class. So if you're doing ETL with full file scans and no data reuse, then you want to probably use a C or an R class, and then also a machine workload with data caching using a C class. And so the RAM available will determine what your data set size is. So, and that's very important for machine learning, because the thing of it is, the more information you have in the RAM for the learning algorithms and libraries to work with, the more efficient that your workload processing becomes. And then for an analytics type of workload, you just want to use an i3. Okay, so now, again, this is database, this is a database platform and technology. So, what are the main considerations, right? For any database, it becomes the holy trinity or quartet is that you have the CPU, memory, disk, and network, right? So let's take a look and see how those relationships play out within the context of the database or the Databricks platform. So for the CPU, there's minimal sharing of resources between threads, right? So there's a lot of parallel processing going on, and they're not looking at one another going, hey, you're not using your resources. Let me use some of your resources because I have a higher workload than you do, right? And that's the executor is managing that, and so that kind of something to be aware of, right? So your cores, you want to be cognizant and trying to get data or look at your analysis of how your jobs are processing and what's going on. So Spark scales well with tens of CPUs cores per machine. And the baseline starting point that's recommended is that you start with 8 Spark cores per executive. And that's from there you start scaling up to see how things work and behave. So you can provision more cores, but you have to be aware that there's an upper limit. So memory. Provisioning nodes that have too much memory can be detrimental as the garbage collection becomes more expensive over large heaps. So we've touched on this, and this kind of reinforces that you don't want to be starting out with large, smaller numbers of, or larger instances of smaller numbers. You want to start with smaller numbers of smaller resources and build up. So, and one thing that's really important to be aware of here, how much memory does it take to load a full data set, right? So one of the things that you do here to understand how much memory that it takes to load this data set is that you take a percentage of the data, you cache it, and then you look to see how much that it actually took up within the Spark user interface to tell you how much is being utilized. And one thing to keep in mind here is that the actual size in memory is not truly that size of data. It's because of tungsten compression, there's a compression ratio going on, but you still take a relative ratio of what's in the user interface to that data set, and that tells you your memory requirement. So let's take a look now at disk, right? Shuffle partitions are written to local disk and then are read from the node selected to complete the shuffle composite. So things get broken down, they get read to a local disk, and then they get rebuilt to rebuild it. So the thing to keep in mind here is that solid state drives read much faster than spinning disk, right? And you're talking orders of magnitude, and this is part of leveraging this to take advantage of the Spark Databricks platform. So when you're selecting nodes for building your cluster, you want to use solid state drives. They are more expensive, but the return is well worth the investment. The other option that you want to select is to provision auto scaling and local storage to acquire more memory and disk as needed. So again, I had alluded to this earlier when we were talking about machine learning. So for networking, the thing to really keep in mind is that once the application data set has been fitted and loaded into memory, the application becomes network bound, right? And where this is significant is when you're doing group bys, joins, and transformations requiring a shuffle. So as you have to start moving the data as part of the shuffle transformation across the nodes, they're having to move across the network. And so that's where it becomes expensive in terms of, you're really limited by the pipe that's available to you to push that data around. Okay, so let's take a look at some of the best practices. So out of the box, you want to use auto scaling and auto termination where applicable, right? So it doesn't make sense if you need it, if you need a cluster for a team of users throughout the day. Another thing too is for developers, right? If they're only going to spin something up, perform a task, look at their results, it makes sense to shut it down, right? Because the thing of it is that you're really, at the end of the day, you're spending resources to execute the processing as well as the storage. But reducing the processing costs, is advantageous in persisting the data in your data lake or blob storage. Another thing to be cognizant of is to use the latest Databricks runtime version to take advantage of the latest performance and other optimizations. Sometimes things do degrade with new changes. I think we've all seen as professionals that a new version rolls out and things start to deteriorate from a performance perspective. So not everything gets ported over to the latest and greatest version, something to keep advantage of, but Databricks is very cognizant of trying to make sure that performance doesn't degrade with as they move forward with the versioning. Another thing to keep in mind is use high concurrency cluster mode for data analysis by a team of users or BI tool. Also, you have the ability to give roles and responsibility via table ACLs, and then as well as having the ADLS pass-through and for security. Another thing in terms of cost containment and management is using cluster tags for project and team-based chargeback. So, again, this can help you to, keep your budget from being burst out by rolling out Databricks, and all of a sudden people are saying, hey, I want to use, all these high-cost nodes and infrastructure. So you can spin it up, spin it down, and then, use it as you need it. Or, for instance, like if you've got an ETL process and you need to keep a hot spare for part of your process to, do a DIM or a fact table lookup with millions or billions of rows, you can spin that up, they can hit it, and then they can shut it back down. So moving on, for, the last part of the cluster best practices here is to use the Spark config tab if certain tuning would make sense for a specific workload. So using configuration to use a broadcast join. Use the event log and Spark user interface to see how different queries and workload executions perform. So, and what those effects have on a cluster health. We're kind of dancing around performance tuning, but understanding how things work and how, the implications of what you have configured and what you're trying to do have a direct bearing on performance. The last couple things here is just to use the configure cluster log delivery, and then also use the cluster ACLs to configure what user or group of users are allowed to do. So you can set roles, responsibilities, and rights using the ACLs. One other really important thing to do here is to pare down data sets. So, a lot of times developers don't need to have a full set of data, right? You can create a standard or a reference data set that qualitatively reflects your production data in terms of data types and sets, and so it does take some effort. However, it's an iterative process, allows for real-time development by caching the data sets, and all the queries return instantly. So you're leveraging, having a data set that's manageable. You can cache it. You're not dependent on saying, oh, now I have to spend all these cycles of waiting for this to get processed and returned. Another thing, for development environment, you don't need large clusters. So again, going back to saving cache, it's pretty important. So you're not blowing your budget on allowing people to have high-end machines and resources. Another thing is if you realize that the things are off, your output's small, because you can just say, hey, you know what, we're going to build a new cluster and reprovision it in a different way, and then you can just say, hey, here's the data set, right? You don't have to go through the work of rebuilding that data set or caching data for them to use. You already have it. Another thing that I think is really important is to titrate based off of that data set. If you know that you have X amount of performance with a proportion of your production data, you can extrapolate pretty easily to say, hey, we think this is the type of performance that we'll get by scaling up and out to get what we need. Okay, so I'm rapidly running out of time here, so I'm going to kind of blow through this a little bit. But in terms of high availability and disaster recovery, one of your recommended best practices is to deploy Databricks in 2 paired Azure regions. And they want to be mapped to different control planes. So for instance, the Eastern US and the Western US will be in different control planes, whereas Western and North Europe will map to the same control plane. And so some of this gives you redundancy, as well as ensures that you have a high availability. So remote odds of a data group going down. However, if the one issue, there's transmission pipe problems or something, you'll have redundancy. So, and the other thing is that you can use the Azure Traffic Manager to load balance and distribute API requests between deployments, especially if you're using a back-end non-interactive mode. So if you're just supporting serving up data. And then also there's some API limits just to be aware of, is that you have max API calls of 1,500 per hour. You can run 1,000 jobs per workspace, and concurrent notebooks limitation of 145 an hour. So just to keep in mind, at the end of the day, Databricks is a database platform and technology. Even though it's all in memory and blazing fast, you're still kind of not constrained, but you're influenced by the infrastructure underlying it. And that's the big thing to keep in mind. So remember, CPU, RAM, disk, network, right? And selecting those from the Azure side to support your cluster is most important. So, thank you very much, everyone. I appreciate your time and interest today. I hope you found this session informative and worthwhile. Cheers now. John?
Hey, Max, thank you very much. That was terrific. So we'll kind of switch gears here, and I'll bring up the screen real quick. Max, do you want to? Are you sharing the screen?
Yeah, hang on a second. I'm sorry here, guys. Let me break out of this. Give me a sec. I gotta get back to the. Where's the screen here? Here.
Okay, thanks everyone. My name is John Bloom, and today we're going to be talking a little bit about Azure Databricks to follow up the great presentation by Max. My topic's going to discuss a little bit differently some of the ETL stuff and go into the actual Azure portal to look at the Databricks. So with that said, welcome to the presentation. I hope you find some value. Databricks is really taking off, and for good reason. So I'd like to just explain a little bit about it. So what we're going to talk about today is a few items, a little bit about me. Principal consultant with Pragmatic Works. I started with computers back in the DOS days with no hard drive. Been working with data for a while. I live in Tampa Bay. So why would you use Azure Databricks? Well, if we look back at history, we started out with the COBOL and we moved to the fourth generation reporting tools, and from there the OLAP cubes and data warehousing, and then big data came along and it kind of disrupted everything because it gave us new ways of looking at the data. With the Hadoop, we had a couple vendors, and the software was free, but you had to pay for the consulting services. And there were some, it opened up a lot of possibilities and doors. It was going to save the world. At some point, they came along with in-memory Spark, which is basically, it sat on Hadoop in the cluster, or you could run it on your desktop. But essentially, it runs a lot faster, has a little different capabilities, and it solves a lot of our problems faster, easier, and it runs in the cloud. So why would you use? We just talked about it. The originators of Databricks are actually the ones who created the Spark language, the Spark infrastructure, and they handed it off to the Apache Foundation, which is, a plethora of utilities and applications that help through the data lifecycle in Hadoop. And the life cycle is Hadoop to Spark to Databricks to Azure Databricks. And the advantage is that it can process huge amounts of data, and it's a cloud native. So what cloud native means is that the data is born in the cloud, which is, it's a lot different than some of the other tools where, you have to move the data around and stuff. So why would we use the Databricks? Well, you can use it for validation, ETL, change data capture, advanced analytics, machine learning. It does a lot, and I think graph as well. So it does its best attempt to keep everything in memory. So while it's processing these terabytes of data, it's swapping everything in memory. Occasionally it has to write to disk. In the Azure world, it writes it to a storage account. And the clusters are super easy to set up and configure. And lastly, you're charged separate for storage versus compute. So let's say you have all this data in your Databricks. It stores it in the storage account, or ADLS, which is the Azure Data Lake storage. And then when you shut down your cluster, the data is persistent on that blob storage, and you're only charged for that lower cost to store the data. Now, when the cluster's up and running, obviously you're charged for compute. So that's a nice feature. It's very similar to HD Insight. So what are some of the benefits? Well, there's tight integration into the Azure subscription because it has to pull the data from somewhere, the data lake or the blob storage. You can also initiate these jobs, which are Databricks notebooks. You can initiate the jobs from the data factory. There's a connector to the data warehouse as well as SQL database. Well, you can read from the SQL database and you can push and pull data into the data warehouse. It's configured using Active Directory, so you can use groups and lock down users for specific users. It also connects to DevOps, which is Azure's source control repo. We started out with Visual Basic, went to TFS, we're at Azure DevOps now. It's a great tool for collaboration. There's also something called Ganglia, which stores metrics. It connects with that. It decreases the DevOps time, so you can actually get to your destination faster. There's support for multiple languages. Scala was designed specifically for this environment to sit on top of Spark. You also have access to Python, R, as well as SQL. So a lot of people in the data world are familiar with SQL specifically, but then some of these other languages, possibly for statistics or once you get in there, it's pretty easy, but there might be a slight learning curve because it's a little different. Back in the SQL days, when you wrote a report, you wrote a select statement, you possibly joined inner outer joins with 7, 10 tables, and you were done for the day. Now it has gotten a lot more advanced where I would say that the world of data and programming and applications is kind of converging because you have all these Legos like Max mentioned, and depending on how you put them together, you can create all sorts of combinations, but we've definitely left the world of simple SQL statements. So there's collaborative notebook environments where multiple people can work on the same notebook at the same time and collaborate. There's revision control within the DevOps. And it breaks down the silos between the data engineers and the data scientists. So a lot of times the data engineers are tasked with taking this data and making it into a model or something that's going to be handed off to the data scientists. And sometimes it's a black box. But in this case, the environment which the notebooks reside, you can see what's exactly happening. How did this data get transformed? What's the source? So it's kind of like self-documenting. So that's good. There's a lot of use cases for why you would want to use this. I mean, in addition to integration to your Azure environment. So we'll go ahead and jump right into the demos if that's all right. So this is basically the environment. And the way that we got here is that within the Azure infrastructure, this is my local account. You know, you go in there and you click on this launch workspace. There's other ways to get there as well, but that's how I did it. Once you're in the Azure Databricks environment, this is what it looks like. So what we have here are workspaces, and you can have a lot of workspaces depending on the users, and then within the users you have a folder. So we clicked on this one here, and once we're in here, you can see that there's a whole bunch of activity occurring. What the nice thing about the notebooks, which I like, is commenting. So when I learned coding back in the early days, I was told to write comments for the next person that's going to support this, and it allows this markup language, which is real nice. You may have seen that in Wiki or something, but it's kind of cool. And then you can document for the next person. And in this case, you can see up here at the top, SQL. So when this notebook was created, we said, oh, the primary language is going to be SQL, but you could also select the other three if you chose. And this here is the cluster, and it's currently running. You can monitor the cluster and set up jobs to run at certain frequencies. From within here, you can do all sorts of file manipulation, and you can clear the results. We have something called widgets, which are similar to parameters. So when you're calling the notebook from Azure Data Factory, you send in the parameters, and then those are accessible. You can also clear the state. So let's go ahead and just look at some sample code, if that's all right. Basically, this is SQL. So what time is it? So we can write, we can mount files and do all sorts of stuff with traditional SQL. So if we go ahead and hit the Control-Enter key here, what we're doing is we're going to ingest this. We're going to mount the CSV file called Diamond, and we've indicated that it has a header. So the job indicates that we're success, which is good, and you can drill down into the details. In case the job fails, you can troubleshoot. And then it kind of has like a file system, not really like Hadoop file system, the HDFS. It's called Databricks DB file system. So within that, it's like a Windows file explorer where you can create folders and subfolders and add documents and all sorts of stuff. And then once those documents are there, obviously, you can pull them in from the data lake or your blob storage or what have you, and then it resides in the Databricks file system. So you can access it, you can mount it. You can mount those files to create tables. So here's a bunch of Databricks source files that are pre-configured whenever you stand up a cluster. And now this kind of looks like SQL, select star from diamond. So what it's doing, in fact, is writing a basic select statement from a table. The table doesn't exist anywhere. There's no database. It's a mounted file. But you can see here that we're getting returned data sets. So let's say you want to put a where clause. You could put where cut equals ideal. See what happens. Yeah, so there you go. You can apply where clauses, but that's just the beginning. I mean, there's a tremendous amount of stuff you can do. I'll go ahead and skip this one because I've already mounted the file. So that's using SQL, and we know it's SQL because it's pre-configured up here. You can also use Python. So in this case, we'll go ahead and execute this command by hitting the Control-Shift key. And in this case, within the Databricks, there's something called Delta. It's relatively new, but it's designed for speed and performance, and we can use it for change data capture as well, which we'll get to in a minute. And here you can do a list. If you're familiar with DOS or Unix, it's kind of like command line. So a lot of people who come from the command line, such as Hadoop or Java or what have you, they get real familiar with the command line, which is nice. And then you can see the files within the database file system. And here's an example that you can do somewhat complex SQL. We're going to select one field. We're going to do group bond account from the diamonds table, and we're going to order by 2 descending. And that looks pretty good. And what's also nice is that out of the box, these notebooks like Juniper or this one here, you can visualize in real time. So obviously data scientists they're not just interested in moving the data around and making sure the joins are proper and there's no duplicates. They want to do something with the data. So imagine a template work environment, web-based, where you can just log in and start playing with the data. So in this case, we could choose another type of graph in real time, and it instantly shows up. Now, if you had to code that from scratch, it might take a while, but it's already like pre-developed and everything. So you can do all sorts of stuff just out of the box. And then, well, there's no mapping coordinates, but you could actually export it and download it to your local hard drive, and then you can send it back to a detailed graph. Detailed matrix. So you can actually do the same thing within the Python, which is kind of cool. So if you execute that, it puts it into a data frame, and a data frame is simply like a container where your values are stored in your columns and such. And then, when you write in Databricks, if it's not your default language, you have to specify the language. And in our case, we always use a % and a Python. And this is kind of like it's like a pointer to, you have to bring in your libraries. Like if you worked in a language like C# or something, you have to, or whatever, you have to import the language so it can reference it. And in this case, if we execute it, it's going to return the color and the price, which is nice. So, that's your basic stuff. Also, I like to show you, it keeps track of your revision history. So you can set this up to point to your DevOps, so you can keep track of your changes over time. You can also look at your available runs in the past few minutes. It goes back in time. This is one of the features called collaboration with the comments. And let's see. Yeah, so I put in some comments. So, you don't have to use comments for job security, but if you're interested in helping the next developer, you can write these comments here, and that way they'll know what you did, and then they can, so you can put comments there. So that's a real nice feature. I don't know if we have that in other languages, that we work in, but I really like that feature. So obviously you can look at the recent files that have been worked on. You can look at the data. You're probably wondering how I got that data into the Azure Databricks. Well, you just drop it in here. You can drop the files into this little wizard here, and it prompts you to create, it mounts the table for you, and you tell it what the delimiter is in the header row and such. There's other stuff, Max mentioned the cluster. Here's where you can create new clusters. You can administer it. You can click this button here to stop it or refresh or what have you, clone it. There are jobs. So let's say we have a notebook that we want to schedule. We can go ahead and click on the jobs button. I created one last night or sometime. And here's the job. I ran it a few times. In fact, it failed. So, a lot of times when troubleshooting, to create the code and put it in production is pretty easy, but to maintain it, that's where the fun starts, because sometimes things stop running and you don't know why. So you got to dig through log files like in Hadoop. You got to dig through the logs to find the error and then research it. But in here, we have that information at your fingertips. So that's a nice thing also. I have another notebook I like to show you. And this one's called Change Data Capture. So what is that? Well, in the world of data, data changes over time. So let's say you start off and you stand up a web application to do travel or something. So within a year, you have 1 million records. And then, so the next day you have 1,000,100 because you got 100 new. So you want to find out of those 100 new records, is it an insert or an update? So what that means is it a new record, or is it a modification to an existing record, or possibly a delete? So there's many ways to do this in the traditional world of SQL. We do have change data capture within SQL Server, and then there's all sorts of ETL patterns that we can use as well. Now in this one, the default is a Scala, and we prefix with the SQL. And what happens is we can create the database. I have a feeling it's already there. So let's see what happens. That's interesting. Hold the phone. All right, so let me just go ahead and open it again and see what we get. All right, so I have a feeling the database is already created, so it may throw an error. And then you just tell it to use the database. This is pretty familiar, writing T-SQL or PL/SQL or something. But it's going to go ahead and attempt to create the database. See, it's either there and it's going to throw an error, or it's going to create it in real time. Now, these jobs, although it's pretty quick in real time, it does take a little bit of time because it has to, process the code and send it. And anyway, we'll let it run. But anyway, let's just move forward on the next query. Basically, we tell it to use the database, and then we can also go back to our SQL and drop the table if it exists. Yeah, it already exists, so it threw an error. It should know to use this database. But in fact, this should run, and then we'll go ahead and drop the table if it exists. 2 of them, actually. And then it kind of gives it a description of what we're going to attempt to do. So I went through the effort of uploading the file 1 and the file 2. They're already in the cluster, so we can actually select from them. And like I said, there's no real table. It's just a mount to a CSV file, and we have all this pertinent information right here. And then we can also do the same for customer 2, and then we can union those. If you're familiar with union, it's basically one query sits on top of another. The all indicates bring back everything. So we can do that. So within Databricks, like I mentioned, we have this delta, and delta is used for speed. It's also used for versioning. So the first time you insert that 1,000,000 rows, you're going to have 1,000,000 rows. The next day, if you're doing a full ingestion, you'll have 1,100,000, or possibly just 100 if you're doing incremental. And we have to identify if those records are inserts, which means they don't already exist, or they're updates, they exist, but we need to update the specific record. So this is the pattern that you could use to do that. And then what we have here, if you're familiar with the merge statement, it's going to attempt to, this customer 2 CSV file has new records by design. So we're going to attempt to compare the 2 files, and it's going to update these fields here if it's an update. Otherwise, it's going to do an insert. So that's what happens there. So we'll go ahead and execute and see what happens. It take a minute to run. So it creates these Spark jobs, and Spark jobs call smaller jobs because there's tasks, sort of like a task tracker in the background, and it's kind of like chunking up the data, and then, but it does it in memory, so it's pretty fast. And then here's where you can identify the differences. Now, like I said, the first time in that 1,000,000 rows that we talked about is version 0. The next day it's version 1. The day after that it's version 2, assuming you're running it every day. So it says, all right, give me version 0 and compare version 1 and tell me what's new. So in this case, we told it if it's an update, we're going to flag it with a U. If it's an insert, we're going to flag it with an I. You could also do the same with the D's for delete. And then, like any SQL, you can describe the table. And then I have another pattern here where you can, so that's assuming that you don't have a date stamp, timestamp to determine if it's an insert or an update. Obviously, if you have incoming data on a daily basis, you would like to have a timestamp so you can identify the last time, just give me all the records greater than yesterday. So if you don't have that, you have to use that method we just showed you. But if you do have a timestamp, there's also a shortcut method. And basically, if you look here, we're doing a last updated date less than this one. So it's a little cleaner, but we're not always fortunate to have that timestamp. So it's basically the same thing, just using the timestamp. What time do we have? 2:50. So that should give you a high-level overview of Databricks and why you would want to use it. And these notebooks, you can add widgets, which are parameters, and then you put them in a folder for production, and then you can have your data factory call that widget, the brick, and The brick could have various languages such as Scala, Python, R, or SQL. It flows into parameter, processes whatever it needs to do. The nice thing about it is that in the application that we're working on now, we store some of these values in Key Vault. So we have access to Key Vault from Databricks. So we can store our passwords, our connection strings, our URLs, whatever we need, we can store in the Key Vault, and that's accessible through the Databricks. We have code for that. Secondly, we have usernames, possibly passwords, that we can instantiate a call to the Azure SQL database for various reasons. In our case, we're calling the control table, but I'm just trying to say that you can call a view within an Azure SQL database and return a data set, and then that data is available within the Databricks to do what you like, store in a variable or what have you. The important thing that I like to mention is that, let's say you go through all this effort and you identify your inserts and your updates. What do I do with it? Well, you can call a command that will save this data set directly to Azure SQL Data Warehouse. So there's one way to do it where it trunks and reloads that table, and there's another way where it appends. But suffice to say, at the end of the day, however many records are here, that's the same number that lands in the Azure SQL Data Warehouse. And from there, you can flow it into your data warehouse, your dimensions and your fact tables. So that's pretty tremendous. If you're talking petabytes of data and you don't want to bog down the SQL Server, you let the Azure ETL Delta framework do your heavy lifting for you. It's pretty fast. It's a well-proven framework, methodology, and it's something that we have implemented. And lastly, I'd like to say that in addition to access to the database and the data warehouse and the data lake, we can also call a routine to save this file as a Parquet file on the data lake. So if you don't want to insert the data directly into the data warehouse, you can save it to, let's say, the curated folder within the folder structure, and you save it as a Parquet file, and then you can mount it using Polybase and still flow it into your data warehouse. So there's a lot of advantages to using this. This is just one example of an easy change data capture and to get familiar with the environment and everything. At the end of the day, you can set it to shut down at like 120 minutes and what have you. So otherwise you can shut it down manually. And so we do that here with the shutdown button. But that's kind of a quick view. So you had Max's demo on webinar on some of the high level stuff, and then we had the interface use cases for ETL. So I hope you enjoyed the presentation. That's all I had to present today. If there's any question, we'd be glad to answer.
Yeah, sure. Let me go ahead and pull them up. How does Databricks handle large data that does not fit into memory?
Okay, so it attempts to put it in memory as best as possible. Unfortunately, it thrashes and it writes it to disk. Somewhere here it says, makes best attempt to keep everything in memory. The Hadoop task bottlenecks on the input-output. And these clusters are so anyway, I think that's one of the limitations on the Hadoop side, is that there's all this data shuffling back and forth, and it has to like reconnect everything at the end. The Spark infrastructure attempts to store everything in memory. Unfortunately, there are cases where the data is just too large to fit. What you could do is, let's say you run these jobs between 2 and 5 a.m. You can actually auto scale your CPUs and your memory, because we didn't talk about that, but when you're setting up your cluster, there's a lot of configurations, and it actually allows you to modify some of that on a schedule. So but that's one way you could handle it, possibly, if you didn't want it to write to disk. I also know that another technique that people are using is they set up VMs ahead of time, and that if they know that there's going to be activity during 2 and 5 a.m., they spin up those VMs and they create a pool. And a pool is a list of available VMs. And as it needs it, it pulls from the list of VMs in the pool. And then when it's done, it puts it back into the pool. So that's another good technique that people are using to handle these large data sets. But still, it's got pretty good speed. I know Azure SQL Data Warehouse can handle a great volume, but traditional SQL servers, the temp DB, if you get into too many rows, the temp DB crashes and you get a call from somebody asking who's running queries. But anyway, I hope that answered the question.
Awesome.
Thank you.
Someone wants to know what a good use case for using Databricks is.
Oh, that's a good question. We're using it for multiple reasons. And one of the reasons that we're using the Databricks is we mentioned the change data capture. But a second reason that we're using it is for validation. So when we pick up our files from on-prem, we flow them to raw. The data factory calls a Databricks notebook that parses the file. So it has a control table and it says, these are the 20 fields attached to this file. Are the columns in the right order? Are they spelled correctly? Are there spaces? The field types. This is supposed to be a varchar. Is it a varchar string? Maybe. If not, throw an error. So we do validation routines. We check for nulls. We look for duplicates. We format the dates in the notebook. And then after we're done, if the file is good, we save it back to stage in the data lake. So we use it for validation. We use it for change data capture. And we also have a use case to pull data from the data warehouse and then flow it into a model using machine learning, machine learning algorithms. And then, the probability, whatever the statistical probability, it's sent back to the data warehouse. So we can integrate that into the pipeline. So that's a few use cases.
Okay. Is this cluster configuration required for ADF, or do we just specify the number of nodes and it's taken care of by Azure?
It depends on the level of security in your organization. If you have access, you could probably spin one up and it'll allow you to pick the configuration that you choose. Now keep in mind there's cost associated with it. There's the premium, which has a higher cost, there's standard, and within that there's all sorts of different flavors depending on what you need. Now when I stood this one up, it defaulted to 8 working nodes or something, and I lowered it to 2, and then there's also a DLL worker. It's like so there's 3 that are running, and I definitely scaled it down for the demo because but if you're in a production environment, obviously you use what you need to run your business. So there are some costs associated with it, but on the project we're on, I believe we're using premium.
Okay. Looks like one more question. How many rows were you manipulating in your example?
Oh, not many. So let's see. So here's some sample data. And if we go to the end, about 90 records with 8 columns maybe. Yes, real minor data, but just for demo purposes.
Okay. I think that is all the questions. So John, thank you for doing your second presentation of the day with Max. We appreciate it. Thank you everybody for joining. The next session starts in about 1 minute or so. So thank you for joining us, and we'll see you on the next one. Bye everyone.
Thanks everyone. Thank you, Liz. Thanks, Max. Bye.